Dear students, with this lecture we start a new group of organs, the urogenital organs. The urogenital organs actually consist of, urogenital apparatus consists of two components, the uropoietic and the genitalia, but both anatomically and embryologically so connected to each other that sometimes we name as a single unit. This consists of two subparts, the uropoietic system, which produces the urine, that consists of the kidney, the main character of that, and the urinary duct system, which consists of the ureter, which leads the ready-made urine to a temporary reserve, the urinary bladder. The urinary bladder is the second one, and the urethra, which leads the urine out to the outside world, is the third one. The genitalia can be divided into two aspects because we differentiate external and internal genitalia. As you know, external genitalia are the organs for the copulation, and the internal genitalia producing the germ cells and temporarily storing them. Also in other aspects, we have males and female genitalia. You probably know pretty much what's the difference between them. Now, let's start with the uropoietic system and with the kidney. As I mentioned earlier, the first thing you have to know when you become familiar with a new organ, what is the function of the organ? Why is it good for us? We have this particular organ. Why is it good? We have a kidney. What are the roles of the kidney? The number one task of the kidney is the water-salt balance. What does it mean? The water and the inorganic salts are absolutely essential for any type of life. Any life form needs that. A couple of 100 million years ago, because when every living creature were in the sea, water and salts were available freely. Whenever some of our brave ancestors climbed out to the dry land, it was always immediately a problem to maintain, to keep appropriate quantity of water and salts. And this was the task of the kidney, to household with the water and the salts. So the kidney controls the water content of the blood, because the most easy to change water content is the blood volume. So inside the cells, the intracellular water content, and for a certain extent, the extracellular water content is pretty much standard. So if you have differences in the water content of the body, it mostly results in a different blood volume. So indirectly, it controls the blood volume. The ions has many roles in our body. It ensures the osmotic pressure, and with this, we can move the water inside of the outside of the membrane, because it diffuses in the direction of the osmotic pressure, and this is the main mean we can control the position of the water inside the body. Ions also has controls. All the ions must have a very standard level in the blood. Otherwise, we have severe organizing problems. Also, it controls the calcium and phosphate, which among others is very important for the buildup of the bone. The kidney makes a very lot of work. 1,700 liter blood flows through every day through a kidney. From that, it makes 1/10 of a filtrate, 107 liter, and finally, it will absorb most of them to make a 1.5 liter urine. Beside the water and salt balance, the other function of the kidney is the excretion. The metabolic end products, especially the water-soluble metabolic end product, is eliminated by the kidney. So these can be surplus material, poisons, and so on. So this is a kind of very important cleaning function. Also has an endocrine function. It produces the renin. This is the most powerful blood pressure controlling agent. Erythropoietin, increasing or controlling the formation of the erythrocytes, the red blood cells, and also produces hydroxycalciferol. This is a D vitamin derivative, which is necessary for the calcium phosphate metabolism. Okay, now let's see the anatomy. What the kidney looks like. The kidney is so characteristic shape, it's a bean shape, that any similar organ in the body named kidney shaped by the doctors. And this is a paired organ. In this case, you can see the anterior and the posterior side of the right kidney. This is about 11 centimeter long, 6 centimeter wide, and 3 centimeter thick. This is the kind of average size, and close to 15 decagram its weight. The surface of the kidney is smooth. In embryonic life is lobulated. Sometimes it's remained that, but mostly it's smooth. This is located retroperitoneally. In this picture, you know, it's a slice, a human slice. This is the vertebrae, this is the back, this is the front, this is the abdominal, these are the guts, and this blue line represents part of the parietal peritoneum, and the kidneys are nicely located behind them. These are not in contact with the peritoneum, just through their capsule. The skeletal topography, you know, this term means that what is the position of this particular organ in compared to the skeleton. If you see from the back, this is located between the 12th and the thoracic 12 and lumbar 3 vertebrae. Maybe the best thing to locate the kidney in X-ray picture is a 12th rib. 12th rib is a little bit oblique, and if we get the middle of the 12th rib, the right lobe, the right kidney is slightly lower because the liver is sitting on the top. The middle of this 12th rib is cutting the upper pole. In the left lib, the middle of the left kidney, the middle of the 12th rib is around at the level of the hilus. The left kidney is pressed a little bit more medially, probably because the spleen is also in between it and the diaphragm. And it's important to know that the axis has diverged down, so it's obliquely located, and that makes it easier for the ureter to get out. It not bend as sharp, and much easier the urine flow. It's important to know that the hilum facing forward, so it's not just flat in the lateral way, but obliquely, because of the bones does that. Consequently, whenever we see an X-ray picture, this is narrower than it should be. So if you see my palm, it has a certain size, but if you turn a little bit, it's apparently narrower. So whenever you see an X-ray, the kidney in an X-ray picture, you have to know that really it's wider than that particular picture. With topography, you know this word means that the organ is in contact with which other part of which other organ. This is relatively complicated, but you have to think about that. In the left kidney, this is a drawing of that. At the top, we have the adrenal gland. Here, it's in contact with the spleen. This is a little area, it's contact with the stomach. As you know, the tail of the pancreas is going to the hilum of the spleen, consequently passing in front of the left kidney. Major area in the lower part is in contact with the jejunum, actually through the capsule and the peritoneum, of course, and also in front of that we have the colon. In the right kidney, most of the neighbor is the liver. The liver has two connections. In this pale area, the liver is directly in contact with the kidney because this is the bad area. Here we have the peritoneum, the visceral and the parietal peritoneum in between and the peritoneum cavity, but still the liver is in front of it. Below that it's in contact with the colon, the right colic flexure. In a small area in the jejunum, of course on the top we have the adrenal gland, and around the hilus, in front of the hilum of the kidney, we have the horseshoe-shaped duodenum. Back, behind the kidney, we have muscles. Behind the medial edge, we have the psoas major. Behind the middle, the quadratus lumborum, and it's little from the transverse abdominis. And this is below the 12th rib. Above the 12th rib, we have the diaphragm, which makes the back partner, neighbor of the kidney. Medially, we have the vertebral column. Between them, we have the muscles, especially the psoas major. Laterally, we have the abdominal wall and the 3 layers of the abdominal wall. Above that, we have the adrenal glands and the diaphragm. Above the right kidney, we have the liver, which is missing in this picture. In the bottom, below that, we have the guts. The kidney is pushed a little bit into the peritoneum, and here the peritoneum goes a little bit back. So below that, we have gut loops. Okay, next chapter is the capsules. The kidney surrounded by 3 layers of capsules, and these are the followings. The innermost capsule is like a normal capsule of the organ. Most of the organs have a thin layer of dense collagenous connective tissue, which is the capsule of the organ, and the kidney also has that. This is what we name the renal capsule or tunica fibrosa. This is strong enough to get off the kidney if you want to do that. You can take it in one single sheet. The next is the adipose capsule. This is about 1-2 centimeter thick adipose tissue, and you can see also the anterior part was removed in picture, but the side and the posterior is visible. This fat belongs to the group of the essential fat. You remember this is the fat tissue which doesn't change in volume, doesn't matter how much we eat or how much we starve, because it does have functional significance. It makes a mechanical and thermal protection for the kidney, and also very important for fixation. Kidney is practically stuffed around with the fat tissue, and if you have a very extreme starving, like shipwrecked or some stupid woman who want to be a photo model does that, then the kidney can slip down. This is what we make the migrating kidney, ren migrans. And the problem is not because we don't find the kidney, but the kidney will turn down a little, well, if you see it, goes down, and the ureter will make a sharp bending, and it makes more difficult for conducting the urine. The renal fascia is the outermost layer, represented by this green line, which takes around that. And you can imagine that it has 2 laminas. This is very similar to a simple folder. So you can see this is here we have a kind of folder, and this is my fist inside. We have an anterior and we have a posterior lamina of that, and also upper and laterally they are fused together. Medially not, because here the structure for the kidney goes, and down is also open, and this has embryologic reason. Whenever we talk about the development of the kidney, we see it will migrate upwards. It's necessary to have an open renal fascia down. Okay, that's about the capsule. Fixation. The fixation of the kidney is through the kidney capsule. The outermost element is the renal fascia, which is fixed to other elements. Anteriorly, we have the peritoneum, which is fixed. Laterally, back and medially, this is the fascia of the muscles, fascia transversa, and the fascia of the other muscles which surrounds the kidney. The renal hilum, you remember hilum is a part of the organ through which the various structures, artery, veins, and other ducts pass. These usually do not go randomly, just a certain area. And the hilum of the kidney has 3 major well-dissectable structures to pass. This is an anterior and this is a posterior aspect of the kidney. The more anterior part is always the vein, the renal vein. The renal vein is a branch of the inferior vena cava, as you in this corrosion preparation you can see, and this for an obvious reason, it passes in front of the aorta. Consequently, it reaches the kidney in front. This is the anterior most structure. The renal artery is in the middle, which are branches of the abdominal aorta, and finally the ureter, which passing in the retroperitoneum. This is the posteriormost position. So here in anterior and posterior aspect, you can see the position of these three structures. This is a kind of pneumodactic, whatever is actually this is how the Hungarian dog barks when you want to remember the anteroposterior sequence of the structure of the renal hilum. Here you can see a summary of all of I had. As you know, all of the lecture documents, including mine, are visible on our internet site, and you can study it for a long period of time. You have all the things labeling there. Now, next chapter is the structure of the kidney. This is what you came across in the exam. This is the most frequent thing what you have to talk about in the exam. This is the kind of longitudinal section of the kidney. What does it contain? Okay, usually students start that it have a cortex and a medulla. That's not true. You say only if you definitely want to fail on the exam, because the main component of the kidney are the kidney parenchyma, the parenchyma, and the renal sinus. Parenchyma is the working tissue. This is the tissue what really prepares the urine, and the sinus are a service area which contains vessels, urinary ducts, and so on. The renal sinus, whatever I described first, actually is a cavity surrounded by a parenchyma, and it's communicating with the outside world through the hilum, or hilus in Greek. What does it contain? The number one contain is an intrarenal urinary duct system. This is the duct system which conducts the ready-made urine produced by the parenchyma. It consists of a pelvis. It's a single cavity which continues with the urethra. Then we have larger and smaller areas. The largest time the greater calyxes, and the others the smaller calyxes. It's very variable individually, but in the average we can say this is definitely we have one pelvis, we have three major calyxes, and we have three major calyxes connected to three minor calyxes to each major calyxes. So it makes a total of 9 minor calyxes. Once again, the real number is very variable. This is just a kind of rule of thumb. The other components of the renal sinus are the arteries. The renal artery usually enters to the sinus in branches and going straight up to the surface, running between the lobes. Consequently, this is what we name the interlobar arteries. Veins, similarly, coming from between the lobe, collected into the renal vein and go to the inferior vena cava. The rest of the renal sinus is mostly filled with fat. This is the continuation of the adipose capsule through the hilum. We have lymphatic vessels. This is not really dissectable, or not dissectable at all. And the lymphatic vessels drain into the para-aortic lymph nodes, which are nearby. As you know, the lymphatic vessels always following the vein of a particular organ, and this is really that coming in together with the renal veins. Finally, it has nerves. Nerves are autonomic nerves, sympathetic nerves, and their task is to control the blood flow. They end up in the smooth muscles of the arteries, and they change the blood flow. This is the fibers coming from the sympathetic trunk, and that component of the sympathetic trunk, which is approximately lumbile 2, which is nearby the kidney, is usually larger than the rest of the one, and sometimes it's named the aortico-renal ganglion. So this was so far the renal sinus. What about the renal parenchyma? This is still not divided into cortex and medulla. Although cortex is more or less continuous, the medulla doesn't form any kind of continuous layer, so they are divided. The units of the renal parenchyma are the lobes. A lobe looks like a kind of ice cone, and this is the medullary part, which is dark red in this realistic picture, and the rest of them is the cortical area. into each lesser calyx, usually 3 lobes open. So this makes 3 times 3 times 3 major calyx, lesser calyx, and lobes. It's meant theoretically 27 number of lobes. This is also in real life variable, can be anything between 15 and 30 in a particular individual. It has no practical significance how many we have. The lobe has a medullary part, this yellow area. This is the renal medulla. Based on this shape, it's also named the renal pyramid. So this is the nickname for the medulla. And that part of the medulla, which is protruded into the lesser calyx, is named the renal papilla. The rest of the tissue, rest of the parenchyma, is the cortex. Cortex can be divided into 3 subparts. This dark blue is the cortex cortices here, which has a pale tissue, at least in this particular picture. The second one is the renal column. This is what goes in between the medullary parts. This is the Bertini column. This looks like the melted part of this ice cone, if you have that. And finally, we have a strange area in between, just above the arcuate artery. And this is a periodically changing different type of tissue. And this is what we name the stria medullaris, or ferrine column. Anatomically, it's part of the cortex. Histologically, this is a periodically changing cortical and medullary type of tissue. Do not mix them. The arteries, as I mentioned, the arteries enter as a renal artery, interlobular arteries, and between them, on the borderline of the medulla and the cortex, we have arch-like arteries named arcuate arteries. In the larger picture, you can see for the arcuate arteries, we have short arteries, small arteries going straight up to the surface, and this is what we named interlobular arteries. The reason for that is because one of the unit of the kidney is the lobule. The lobule is an area between 2 interlobular arteries. This histologically, it's has different. In the middle, we have vertical tubes, and on the outside, we have a round structure. This is what histologically we mean, we will see later on, medullary and cortical type of tissue. The whatever is straight, like a radius of a screen, going up straight in the middle. This is when the radiate part, pars radiata lobuli cortices, and whatever is coiled up in the 2 sides, this and this is the pars convoluta lobuli cortices. Rest of them will be described whenever I talk about the histological structure. Here you can see a very nice corrosion preparate. You can see in the corridor of the anatomy department in the cabinets. This is where the veins, the arteries, and the ducts were filled with different color plastics, and you can see very nice the structure of the kidney. Okay, that was about the anatomy of the kidney. And let's jump to the urinary tracts. The urinary tracts start inside the renal sinus, and this is what we summarize as intrarenal urinary duct system. These include the calyx and the lesser and the greater calyx and the renal pelvis. The renal pelvis continues with the ureter, which goes down in the retroperitoneum, behind the peritoneum, of course. And in topography, it's worth mentioning 3 notable crossings. Once it goes behind the gonadal arteries. Gonadal artery is a common name of the testicular and the ovarian arteries, because if you are not interested in, for some reason, whether it's male or female, we name gonadal. You say testicular or ovarian whenever we specify the gender of the owner. So the gonadal arteries, the very same way both males and females go, and they're passing in front of the ureter. That's worth remembering. The second crossing of the ureter is the common iliac artery, in which the ureter is in front, And the third crossing differs. This is a male picture, and this is the vas deferens, and you can see the ureter is coming behind the vas deferens. Very similar situation, just a little bit difficult to see through, is the females. When the uterine artery is, also it's passing in front of the ureter. And that makes a lot of very important medical significance, because unfortunately, many of the women, after the fertile ages, 40, 50, the uterus has problems and should be removed. And the first step of the removal of the uterus is the binding the uterine artery. And because technically, at least for the patient, it's much easier to remove the uterus through the vagina. It has a very little area and relatively easy to mix to ligation of the ureter and the uterine artery. And if you do such a surgery, you have to be very careful not to mix these two. Otherwise, you can kill the kidney. Unfortunately, it frequently happens. The blood supply is very important and critical. It has a segmental blood supply, so it doesn't have an own big artery which follows the ureter, but from a short segments has different arteries from the environment. This is why important. If you make any surgery on the ureter, never lift it up, because you break these little arteries. The arteries are small enough not to get a kind of significant bleeding, so it's not really alarming. But if you break this artery, a piece of the ureter will die in a few days. So after operation, in a few days, the patient becomes a terrible condition because urine is flowing in the entire retroperitoneum. So try to avoid that. Do not lift this ureter. Just keep the small vessels then. And this is what I wanted to talk about today. Thank you very much for your attention.